Hello, everybody, and welcome to our Wednesday Echo Live program coming to you from the Michigan Science Center's Echo Distance Learning Program. We are so excited today to talk to you about another fun, exciting STEM topic. If you haven't done so already, go ahead and introduce yourself in the chat. If you are joining us here in Zoom, YouTube, or Facebook, tell us who you are, where you're watching from, or if you can take a look at our topic today. Maybe you could start by telling me, what is your favorite invention? Now, inventions can be just about anything. It could be something that helps you in your daily life. It could be something that you invented to solve a problem. It could be your favorite toy. An invention can really be anything. It's really about what you use it for. And there's really no right answer, but I'm curious to know if you're out there watching and able to participate in the chat, tell us, what is your favorite invention? Now, today we're going to be highlighting some accidental inventions, and some of these were invented on accident. Some of them came out of doing science in other ways, but I thought it'd be fun to talk about some of my favorite accidental inventions and inventors, and highlight some of the scientists behind them. Now, before we talk about any of these inventors or the inventions, we need to first cover something that we've talked about here on Echo Live quite a few times. We need to talk about the invention process. And the best way to explain the invention process ties to our Smithsonian Spark Lab that we have here at the Michigan Science Center. Now, the Smithsonian has all sorts of resources for young inventors that describes the history of invention. And if you're interested in pursuing invention or you have a great idea, visiting the Smithsonian's website or tuning in here to the Michigan Science Center Spark Lab is a great way to start yourself off on this journey. Now, let's make sure, I think my share might not have gone there, so let's try one more time just to be extra sure. Hopefully you're able to see my screen. If not, you might need to let me know in the chat and I can do a reshare here. But this over here describes the invention process. First, we start by thinking of an idea. That's really how any idea for any invention or scientific discovery has started, is that a scientist or an inventor had to think about something. They had to think about a problem or think about a concept, which inspires them to explore it further or do research. So we can see we have a magnifying glass here to note exploring it, doing your research, collecting information about your idea. Then any good inventor will do a sketch or a mock-up or a kind of design for their idea. This could be a drawing, it could be some math, it could be anything that helps you to get your idea out of your head and onto paper so that you can share it with others, or maybe not necessarily paper, but maybe onto the computer nowadays would be just as good. You can also create it, right? So once you have a good sketch or a good plan, it's time to try to create your invention. So you try it out, test your invention, and then of course the most important step is tweaking it. Once you try out your invention, it might not work the way you thought it would the first time. It might work better, it might work worse, or there might be some modifications that you need to do. Now, the deceiving thing about this photo is it seems as if this invention process is linear, that you have to follow these steps in order. But the secret is you really don't, right? Because after you tweak your idea, you can't just go right on to selling it. You've got to try it again. If it really doesn't work, or there's some major changes or surprises that you found during your process, you might need to go all the way back to the explore it step and sketch it, create it, try it again, tweak it again, until you've really perfected that invention and you are ready to sell it, which is always your final step here on our Spark Lab invention process. Now, I want to start by talking about one very famous scientist who most people might not consider to be an inventor. We're talking about Isaac Newton to start off. He is certainly one of science's most famous and innovative minds. Now, while everyone is innovative, Isaac Newton is by far one of the most important scientists, even to this day, even though he lived a very, very long time ago. Now, Isaac Newton famously worked on a concept called gravity. And it would not be fair to say that Isaac Newton invented gravity, because gravity has been around long before Isaac Newton, and really even long before the Earth ever existed. Gravity is the fabric that holds together our universe, and so no one person invented gravity. But Isaac Newton gets a lot of credit for being the first one to take that first step in the invention process and thinking about gravity as a concept. And then he explored it further and told us that gravity works because any object with mass will create a gravity well. It will pull other objects with mass towards it. The most massive object has the most gravity. And when we are standing here on Earth, of course, the most massive object in our vicinity is always going to be the Earth. Once we leave the Earth, right, our Earth is attracted to the sun, which is the most massive object in our solar system, but gravity works outward, right? Our sun is being held into place by objects with even larger mass than the sun, but Isaac Newton is credited with really diving into this concept of gravity and figuring out how it works, or at least as far as we know so far. Now, just to test it out today, just to make sure that gravity is still working, that Isaac Newton's invention, or really innovation, or maybe just concept that he got to kind of take credit for discovering, is at play. I've got a cup full of water, and as long as gravity is working, right, the Earth is going to be the most massive object. So if I take my first cup of water and pour it down into the other cup, once I tip the cup over, right, gravity pulls the water down into my second cup there. Thankfully, I had the second cup there to catch the water, so it didn't make a huge mess here on my table. But let's go ahead and try it out one more time. Take our cup full of water, pour it back into our other empty cup. Here we go, and oh boy. You know, maybe Isaac Newton's idea wasn't so foolproof after all. Huh, look at that. I'm shaking, I'm shaking, I'm shaking. There's no water on the tray other than maybe a couple drops that I spilled, but just where did the water go? I think this cup is pretty heavy, so the gravity must have been turned off. But that can't be the case, right? Because none of my objects on my table are floating away. I'm not floating away. My table's not floating away. Someone out there in the audience, maybe you can let me know just to make sure that my studio is not the exception. If you're still sitting in your seat, is your gravity still on where you are? Let me know in the chat. Are you still out there, still able to type on your computer? But I'm noticing something really strange. As far as I can tell from looking around my room, and as far as I can tell from your responses, gravity is still working. And so that means that I must have played a little bit of a science trick on you. Inside our first empty cup, I put a little bit of a surprise. This cup was not actually completely empty. Inside the cup, I had sprinkled just a little bit of something that we call water gel. And water gel does exactly what the name suggests. It takes water and jellifies it or solidifies it. Water gel started off as a white powder, much like the white powder that I have in this clear cup here. But what we say water gel is it's called a super absorbent polymer. We've talked about polymers a few times here on Echo Live, that polymers are long chains of molecules. And what's special about this molecule is that when it absorbs water, it actually solidifies, and it can absorb up to 100 times its weight in water. So just a very, very small amount of powder, about the same amount as in our clear cup here, was able to absorb this water, lock it into place, and turn it into this very fun, squishy solid. Now, this stuff is pretty important in many people's daily lives. And if it's not important in your daily life now, it was probably pretty important in your daily life when you were a newborn baby, or more importantly, it was probably pretty important in your mom's daily life when you were a newborn baby, because this super absorbent polymer, this water gel, that's the same stuff that we put inside disposable diapers. So it works really well, right? When a liquid, whether it's water or something else, touches this polymer, it solidifies it and stops it from running away or making a big mess. And so we put this same powder in disposable diapers. Now, the first inventor that I want to highlight is a woman named Marion Donovan. Marion Donovan was actually an extremely prolific inventor, and she's a very interesting person in STEM history because Marion Donovan actually was granted 20 different patents from 1951 to 1996. Now, at the time, Marion Donovan was not considered to be a scientist or an inventor because most of her inventions had to do with solving problems or issues in her daily life. So she was credited with inventing the first disposable diaper, which you can see on her table there. She called it the boater. We also credit her with inventing the dental floss sticks. So rather than taking dental floss on a spool and putting it around your fingers to floss, she invented those dental floss loops, which are pretty convenient. And now to this day, we definitely consider Marion Donovan to be a highly important inventor in STEM history because she did what any inventor should be doing. She looked around her daily life as a mother and a wife and someone who took care of her home, and she identified problems and engineered solutions. So 20 different patents and 20 different inventions in just a very short period of time we can credit to Marion Donovan. But we said today's program is about accidental inventions. Now I have this other white powder here, and this stuff is not water gel. It's something very similar. It's something that we would also consider to be a super absorbent polymer, but this one behaves very, very differently. This was actually invented on accident when someone was working to solve the same challenge that the disposable diaper or water gel issue was. So someone was trying to invent a polymer that could take a large amount of water, so much more water in this glass than the amount of powder in the other one. But they were trying to find something that could absorb that water and keep it from making a huge mess. Lock it into place and make it for easy cleanup. Now, this stuff is behaving dramatically differently, not doing the same thing as our water gel at all. Instead of just solidifying and turning into one nice little clump of water gel, this super absorbent polymer is growing. It's expanding as it absorbs that amount of water. You might know this stuff more closely as Inst Snow because it turns into this very fun, fluffy white powder that looks just like real snow that we would see falling from the sky or accumulating on the ground. But this stuff is not snow. It's not frozen water. I've not done anything to change the temperature of this snow or to freeze water into a solid. And to the touch, this stuff does not feel like snow. It's really soft and fluffy, but it is not cold. So unfortunately, this Inst Snow would not make a very good disposable diaper material, right? Because we would certainly not want baby diapers to expand and grow as they absorbed liquid. That could be pretty disastrous and pretty difficult to clean up. But even though this scientist was not strictly successful in solving the challenge they sought out to solve, we got something pretty fun and cool out of the process, right? And so that takes us back to that invention process not being linear, that you can find success and you can make discoveries even from your own failures. Inst Snow is able to be purchased online. If you just look it up, type in Inst Snow onto Amazon or into your search bar, and you can purchase this stuff. You can feel it for yourself. And it's really one of my favorite stories in the invention world because it's something really fun that wasn't necessarily invented on purpose, but it's something we love and use all the time here at the Michigan Science Center. Now, we have another kind of famous, we have a very famous invention and a not so famous inventor to feature next. We're going to talk next about the microwave oven because this is a pretty famous story of how inventions can be discovered when you're not out there looking for them or trying to solve an issue necessarily. The microwave oven is credited as an invention to a man named Percy Spencer. So not a lot of people familiar with his name, but hopefully you all will be today after tuning into our Echo Live program. And Percy Spencer, long before he invented the microwave oven, was already a very, very accomplished scientist. He was a well-known physicist, and he worked in a lab with equipment called magnetrons. And magnetrons do pretty much exactly what they sound like. They're like giant super magnets. And they were using these magnetrons for other reasons. But what Percy Spencer discovered is that every time he walked near one of these magnetrons, the candy bar that he had inside his pocket would melt. It happened every time, and other scientists were noticing this too. Percy Spencer is credited with this invention because he was the first one to take that second step in the inventive process and explore that idea, to really ask the question, why is this happening and how can I use it? Now, we've talked about microwaves and microwave ovens here on our Microwave It episode of Echo Live. We know that microwave ovens work by vibrating water molecules back and forth, back and forth, back and forth very quickly. And we know that vibrations or movement can be observed in the form of thermal energy or kinetic energy, which is also called heat. So microwaves emit this frequency of light, the same frequency that the magnetrons in Percy Spencer's lab make. And he turned this into a device that now almost everybody has in their home to do us a lot of good. I know that I use my microwave almost every single day. It's hard for me to imagine my life without the microwave. So thank you, Percy Spencer. This is something I love and I love to use. Now, our favorite thing to do, though, here on Echo Live is not just talk about how a microwave works and how we can use it to heat up our food, but of course, we want to do some do not try this at home science with it. So, of course, I brought some of our favorite do not try this at home microwave experiments, and we're going to stick some stuff inside this microwave of science that you should never, ever, 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 ever stick in your microwave at home. Let's start with one of our classics, which is a CD. Now, CDs are mainly made of plastic, but the most common thing we're told to never put inside their microwave is metal. And every CD has a thin layer of metal foil, which gives it that kind of reflective coating. And that piece of metal is very, very thin, but that's how we're able to encode information into a CD. Now, let's go ahead and stick our CD inside our microwave oven. Of course, I forgot my tray. Thought it'd be fine without it. But let's go ahead and in just a second, let's see, I'll change my view just a little bit here. We're going to add just a few seconds to our microwave, turn it on. We'll notice a bright flash of light inside there, or at least I can here in my studio. And then let's go ahead and just in only 10 seconds, something pretty interesting has happened to our microwave. You might notice it's a little bit melted. It certainly got warm or heated up. And so safe science would say that I probably shouldn't go ahead and reach in and touch it with my hands. Just to prove that idea, let's go ahead and take a temperature reading with our IR or infrared thermometer. If I point it at my CD, we can now see that that CD, after just 10 seconds in the microwave, is at 137 degrees Fahrenheit. Way too hot for me to touch with my bare hand, hence why I brought my handy dandy safety gloves here, so I can use those to take out our CD. And then let's take a look. Look at that foil inside. It has cracked. There was definitely some sparks inside our microwave as we turn this on. A pretty good demonstration of why we should never, ever, ever put metal inside your microwave at home. Leave that to us here at the Science Center. We don't care about this microwave. We'll get a new one when it breaks. But you definitely don't want to do that at home, so you can keep using your microwave to heat up your food. My other favorite science experiment to put inside our microwave of science here involves using this little Ruffles chip bag. And Ruffles chip bags, or all chip bags really, have a foil coating on the inside, just like our CD does. So on the outside, it doesn't look like it's made of metal, but you probably saw that bright flash of light. And in just 6 seconds this time, take a look at our little chip bag. If I use my temperature reading here, This one got even hotter, 188 degrees Fahrenheit. And again, all this is to do with sending those microwaves, that frequency of light, through these objects. Metal objects are specifically dangerous to put in the microwave because they develop a charge, and that charge can very, very quickly vibrate those molecules back and forth, generate a whole bunch of heat. We've created like a little Ruffles bag shrinky dink, which is very, very hot and smells very, very bad. So to combat that bad smell, let's go ahead and put our very last experiment into our microwave of science. Inside this glass beaker, I have a half of a bar of ivory dish soap. Now, we said that this all works because of kinetic energy, but inside a bar of soap, there is water. We can't see it, but there is water inside. And when water heats up, it gets very, very hot, like everything that we've put into the microwave so far, it will start to grow, right? It starts to grow because it will go from being liquid water trapped inside that bar into gaseous water or water vapor. And water vapor takes up way more space than solid or liquid water will. So after just a few moments inside our microwave of science, take a look. Our bar of dish soap has trapped all of those really, really hot, really far expanded bubbles of air, so really, really hot, almost 180 degrees Fahrenheit, and trapped them inside that solid ivory soap. Now, this is the only experiment that you can try at home if you'd like to. Make sure that you use a microwave safe dish, something like Pyrex glass, or another microwave safe container that you have at home. Don't use paper, use something glass. And then you can use only ivory dish soap for this. If you use another type of soap, it's not necessarily dangerous, but ivory soap definitely gives you the best results. And in just a few minutes, this will be cooled down enough for me to touch. And we've actually created a big fluffy soap ball that you could use to turn into powdered soap, or turn into soap that you can use to wash your hands or your body in the shower. So super fun, but we can accredit why we have this microwave to Percy Spencer and his thoughts as he was walking through his lab working on something totally different. So he took something, again, that he noticed in his day-to-day life and used it to his advantage. Now, scientists don't just make really functional things like the microwave oven. They also are the reason for a lot of the small things that we have that bring us joy. Toys, like we said at the beginning of our program, those are inventions too. One of the most famous toy inventions comes from another man in science, another famous scientist named Lonnie Johnson. And Lonnie Johnson invented the Super Soaker squirt gun. But that's not all Lonnie Johnson did. Lonnie Johnson, long before he invented the Super Soaker, was, much like Percy Spencer, was already a pretty accomplished scientist. He worked at NASA and the Jet Propulsion Laboratory, or JPL, for about 12 years, and his specific interest was working on air pressure and rockets. So he has contributed a lot to science and a lot to space exploration and technology. But since Lonnie Johnson was working on this concept of air pressure and how we could use air pressure to launch rockets, he took that and turned it into something that is fun for everybody, which is a air-powered water gun or an air-powered water cannon. Now, the way a super soaker works, right, I'm sure we're all pretty familiar, is that when you pump the pump part of your super soaker, you're pushing air molecules into a closed chamber. Air, even though it's invisible and we can't see it, is definitely made out of matter or molecules, right? We saw that with our expanding bar of soap, is that even though water vapor or gas is invisible to our eyes, it still takes up a lot of space. And so when you pump and pump and pump the water gun, you're adding pressure to the chamber. When you squeeze the trigger, you release that pressure, and the air wants to rush out of the super soaker. If you filled it with water ahead of time, some of that water will get taken with your stream of air. The concept is really, really simple, right? adding pressure and then releasing pressure, the air will take any object you put into the canister with it, as long as it's light enough to be carried. This same concept is the way I built our air-powered confetti cannon here at the Science Center. And you'll notice that it has a lot of the same parts that we just identified in the Super Soaker. And oh boy, instead of using, let me go back to my PowerPoint. Instead of using a pump for your hand, well, I'm still going to pump with my hand, but I bought a bicycle pump. And I'm going to hook it up into my confetti cannon here. We'll add in air, just like we would with a Super Soaker, by pushing in invisible air molecules. So I've hooked up my foot pump here. Normally this would be on the ground. And by pushing, I'm actually pumping air through this cylinder into my closed container. So I'll make sure that this is locked on there really tight, only allowing all the air to travel from our pump into the cannon. And I'm not letting that air escape. Now, instead of using a trigger mechanism, what I have here is a switch, a way to open and close the valve. So right now, our switch is closed. The valve is closed. And so when I pump our pump here, that air has nowhere to go. It's all being pressurized or stored inside our PVC or our plastic tube. It doesn't take very many pumps here because just a small amount of air is enough to cause pressure inside the chamber. Now, the only thing I did before the program was here into our tube, instead of adding water, because I work with a lot of electronic devices here in the Echo Studio, instead of water, I filled this tube with some confetti. I'm going to aim it right up high towards the sky, tilt my camera up just a little bit. And all we need to do, just like with the Super Soaker, is release the pressure. The air will rush out the only opening it can leave through, and it should take the confetti with it. So let's go ahead, try out our confetti cannon in 3, 2, 1. Whoop. Uh-oh. There we go. 2, 3, 4, 5. All right, our pressure has built. Thanks for bearing with me here. We're going to launch our cannon in 3, 2, 1. Ta-da! Confetti all over my camera now. But again, this is a super simple design, something that could really easily be created at home. I'd say this whole cannon in total probably cost me less than $10 in terms of PVC or plastic tubing, which you can get at your local hardware store. I had to glue some pieces together. I got the valve from the same place, and then this bike pump was really inexpensive. You can get it from your local bike store or local kind of home goods store as well. So that just about brings us to the end of our program for Echo Live here today. If you have any questions about the inventors or the inventions that we've featured so far, feel free to ask them in the chat. I'd love to answer a few before we go. We are, again, talking a little bit about the Spark Lab invention process. So if you're interested in learning more about this, you can visit the Smithsonian's website. You can also come visit us here at the Michigan Science Center to try out your hand at invention in our Spark Lab space. As always, while we're waiting for any questions to come in, this is a great time to thank Ford and Denso, who have sponsored Echo, allowed us to bring you these free science programs every single week. But quick announcement, since next week is a holiday, there will be no Echo Live next Wednesday. We'll pick right back up the first week in December. I believe it is December 2nd. And so you can catch us live on Facebook, YouTube, and right here in Zoom, Wednesdays through the end of the year. Let's see. Amy asked a question in the chat. Amy asked, do we know the ingredients of Inst Snow? And that's a great question. Inst Snow doesn't necessarily have ingredients because Inst Snow is the ingredient. Inst Snow is a substance that was created in a chemical lab. We said it's a very specific polymer or chain of molecules. And it probably has a very long chemical name that I wouldn't be able to say out loud. But the special thing about it is when it comes in contact with water, those molecules will rearrange themselves, flip back and forth, and take up way more space, which is why our Inst Snow grows instead of turning to a solid and locking up like our water gel did. Good question. Good question. If you're interested in finding the chemical formula of Inst Snow, it's probably written on the package too, because most toys have to kind of disclose that sort of information. So you can certainly learn more about Inst Snow online, or I'd be happy to look something up for you after the program if you send me a message in the chat or via email. So until next time, thank you everyone so much for tuning in. I hope you have a great holiday next week. I know I'll miss you all dearly, and I'll see you the week after that here on Echo Live. Until then, have a great day.